Hey everybody, new video today. It's ionic compounds. I already got a bunch of stuff written up here because we're going to try to work through it quick, but we have ionic compounds. Ionic compounds involve ions. If you remember, ions are charged particles, so they're elements that have a positive charge or a negative charge. And we have two types of ions. We have cations and we have anions. We briefly mentioned those previously, but to clarify, cations are positively charged elements or positively charged particles. You can see like Na plus. That would be a cation. One way that people decipher this is cats have paws and cations are positive. You know, to each their own. Then we have anions. Anions are negatively charged ions like Cl minus. So you can see that there. Now, we already went through all these previous knowledge, but take them down because you probably forgot. But new today are ionic compounds. Ionic compounds involve a metal and a non-metal bonding together. So that's different from covalent. If you compare that to your definition of covalent compounds, covalent are two non-metals bonding together. Well, ionic is different. It would be like sodium and chlorine. It's a metal and a non-metal coming together. And so our non-metals are mostly on the right side of the periodic table. Like you should have this marked from previously. And our metals are on the left side of the periodic table. So typically it's going to be something from the left side of the periodic table, sometimes from the center, but mostly from the left side of the periodic table, coming over and bonding with a nonmetal from the right side of the periodic table. The metals are always going to be cations. They are going to lose electrons, so they'll become positively charged. And the nonmetals on the right side are going to gain more electrons, so they're going to become negatively charged. And in the end, the reason they do this is because each element will end up with a full outer shell, which we've talked about. That's what every single element wants, is to end up with a full outer shell. And so when an ionic compound comes together, it's a metal and a nonmetal, and they both end up with full outer shells. Now, a major difference between an ionic compound and a covalent compound, if you remember covalent compounds, they share electrons. They're polite, they're nice, they're best buds. So that's awesome. I'm like a covalent compound because I'm a really nice guy. I'm a really good guy, you know? Just being honest. Whereas ionic compounds, different because they transfer electrons. So a cation like sodium will actually give away its electron to chlorine. So you can look at it in two ways. You can look at it like chlorine is stealing the electron or sodium's giving it away. Either way, it's a full transfer. They are not sharing electrons. They are transferring electrons. So ionic compounds transfer electrons. So that is a major difference between these and covalent compounds. So right here, this is all the basics of ionic compounds. The main thing you need to remember is that it's a positive cation combining with a negative anion, and it's metals and nonmetals. So those are the major differences. So if you haven't gotten all this down, pause for a second and make sure you have all of this down because we're going to start doing some examples. We'll do them down here. I'll leave this up. So examples. We got a metal and a nonmetal. So let's think of a metal. We'll go with sodium is a metal. Find it on your periodic table. When you see sodium, you'll notice it has one valence electron. One. So that means when it becomes an ion, when it becomes a cation, it's going to have a +1 charge. Then we have chlorine. Chlorine, when it has 7. 1, 2, 3, 4, 5, 6, 7. Now we've talked about both of these elements before. Chlorine has 7 valence electrons. So it wants to gain one more, and then it'll be awesome. It'll be like me. It'll be a noble gas. Everybody wants to be a noble gas. That's why it's like me. And then we have sodium over here, who only has 1 valence electron. So remember, we've talked about this before too. It's easier for sodium to get rid of 1 than it is for sodium to gain 7. So sodium wants to get rid of 1, and chlorine wants an extra 1. So it's a perfect relationship. So it's going to form an ionic compound. Sodium, the metal, is going to give away, it's going to give its 1 valence electron to chlorine. And it's going to put it right here. Boom. Boom. Okay. Chlorine now has 8 valence electrons. Chlorine is happy. Sodium got rid of 1 electron, so it's also going to end up with 8 valence electrons because it got rid of 1, so it'll get rid of its whole outer shell and end up with 8 valence electrons. But in addition to that, let's think about the charges. Sodium gave away an electron, so it's going to have a +1 charge. Chlorine gained an electron, so it's going to have a -1 charge. You see how those go so well together, a +1 and a -1? One important thing about ionic compounds is the net charge has to equal 0. So the charge between the two ions, +1, -1, has to equal 0. So if we had one over here that was +2, and this was -1, then we would need 2 of these to equal one of these, right? Because it's got to equal 0. We'll get to that in a second. But NaCl, +1, -1, it balances out, gave away 1, took 1. They're both happy. So our compound comes together looking just like this, very simple. NaCl, one of each. Sodium chloride, looks awesome. Go team. Oh, it's a great. Life is good. Life is good. Okay. Now another example where we would have different charges, so we'd have to figure something out. We have Mg. Find Mg on your periodic table. How many valence electrons does Mg have? You're right, it has 2. 1, 2. So that means it's eventually going to have a 2+ charge when it gets rid of those, right? Because it's got to get rid of both of them. It's not just going to get rid of one. So 2+. We'll use Cl again. So find Cl. Cl, you know it has 7 valence electrons. So it's eventually, when that time comes, it's going to have a -1 charge, right? So 1, 2, 3, 4, 5, 6, 7. This will have a -1 charge because it's only going to take 1 electron from magnesium. Magnesium will have a 2+ charge because it needs to give away 2. So it's going to give away 1 right here to chlorine. This is going to make chlorine really happy because it's going to give chlorine its 8th valence electron, and now chlorine's happy. It's a -1 charge, and it has its full octet of electrons. Magnesium, on the other hand, is very unhappy with chlorine because there's only 1 chlorine, and chlorine can only take 1 of its valence electrons. But magnesium is not going to do this deal unless it can get rid of both. Therefore, chlorine has to bring another chlorine with them. Yeah, there has to be 2 chlorines for 1 magnesium because this has a +2 charge and this has a -1 charge, and our net charge has to equal 0. So there's going to be another Cl right here. So Cl, we have 1, 2, 3, 4, 5, 6, 7. Magnesium is going to give this electron to this chlorine, giving this chlorine a -1 charge. And now, you see why we did that? Magnesium has a 2+ charge. It has to equal -1, -1. Pretty cool, right? So when we write out our chemical formula, it's going to be Mg, because we had 1 Mg with a 2+, and then a Cl2, just like that. That's pretty cool, right? So they're going to even out because this has a 2+ charge, this has a 1- charge. Therefore, we need 2 1- charges to cancel out the 1 2+ charge. See that? Excellent. Okay, we are going to erase this, and I'm going to, that's our last example. You're going to have plenty of examples to do. I'm going to very quickly go on to naming ionic compounds, and this is super simple. Naming ionic compounds. Okay, so naming ionic compounds. The first thing is the metal. Second is the non-metal. So the metal comes first, the non-metal comes second. So the metal would be like Na, that's like a metal. So Na comes first, like a metal comes first, and then non-metal would be like Cl would come second. The additional rule is this has to end in "ide." So it would be like sodium chloride. Those are our only rules. The metal comes first, the non-metal comes second. That's actually really easy because if you look at the periodic table, you read it left to right. The metals are on the left, the non-metals are on the right, so you just read it in order. Sodium chloride, just like that. The only rule you have to remember is that the non-metal has to end in "ide." Even if you have like magnesium, like you had MgCl2, right? We just did that example. There are no prefixes in ionic compounds. So you can always know if it's an ionic compound if there's no prefix at all. Covalent, remember, we had prefixes for everything. Ionic, there will be no prefixes. It's also metals and non-metals. That's the other way to tell. So magnesium chloride, it's just going to be magnesium chloride. No prefixes, no nothing. You don't have to worry about this too. It's still the same name. Even if it was just Mg2Cl4, it'd still just be magnesium chloride. So metal comes first, non-metal second, and then make sure you end it in "ide." And that is all I have for you today. Hope you have a wonderful day and a joyful holiday season. And until next time. Bye.